Right, I had to click the go live button on the dashboard. Let's see if that's working. All right.
Right.
Okay, trying again. Hello, Flat Earth researchers, debaters, and debunkers. First time going live with a Hangout, and I'm joined by Al, Conspiracy Cats. Be great if people in chat could let us know if everything's streaming okay. And Al, just say hi, just to make sure your sound's okay, if you can.
Yeah, hey, how you doing? You all right?
Let's have a look, see what's going on there. Okay, we got FPV Angel working okay here, Nick. All right, lovely. Okay, sounds good. Thank you, No Label. All right. Celine Dion, okay. All right. Oh dear. All right, lovely. Orbs Realm, good one, nice one. Yeah, just thought it was about time we both shared our views live rather than bouncing videos backwards and forwards, and basically see how it goes. No real plans, no real agenda, but obviously the title is Science, Fact and Fiction, so maybe we could at least get some ideas or establish what each of us might assume is science fact and science fiction, and as far as I understand, Al, you're a science teacher. Yeah, are you still doing
that? Very, very close to the end. I went self-employed last year, so I'm still spending little bits of time in school, but mainly tutoring now. So I was doing it for 2001. I trained. So I was full-time in school until Christmas last year, and we're looking at really my last few weeks of spending any time in school at the minute. So about to break free.
Okay. Is that something you've done since leaving school?
Uni? Yeah. Well, I took a year out. I worked in a lab for a year. It was boring work, just analytical work in a quality control lab. And then, I retrained to go straight into teaching. So, I had one, apart from that 1 year out, it's been a long slog, about half my life now, nearly. It feels more.
Yeah, flies by, eh?
I had her when I
started. Yeah, me too, yeah. Lost a lot over here in Thailand. Hi everyone in chat, thanks for coming along. Maybe we'll try and pay some attention to it in a few seconds. Just wait for a few more people to come in. If I can just put across what I've always wanted to put across was since getting into this in 2015, I think, was I could see that there are a lot of intelligent people, smart people, inquisitive, curious people with a lot of questions about life, the universe, and everything, who were having some ideas. And obviously, it comes under the conspiracy banner of all the other stuff that goes with it. But personally, for me, it was something I wanted to look into. The whole flat Earth, globe Earth thing, and I was frankly I was possibly naively surprised at the amount of, to put it frankly, hate that was directed towards people looking into the flat Earth, and that's always from the start. That's always been my idea, is to kind of build some kind of bridges of understanding. At least say, hey, there's people out there who are questioning what this place is, where we are, questioning reality, and they seem to have good reason to do so. Don't be so hard on them. But obviously, I've felt the brunt of that.
Yeah.
But as I said, possibly naively thinking that that wouldn't be the case, or just, but that's that really, so it's gone on from there. The videos have come, and you kind of came along, and give us your first impressions of how it all came, how this whole thing came to you, and what your initial reaction was.
Well, it came to me, and I think this, I don't know, I mean, I've said this on a few streams, but, a lot of people sort of accuse me, not in a nasty way, but accuse me of not wanting people to ask questions about stuff and not wanting kids to be, reaching out and researching for themselves. But the way this actually came to me was one of the kids that I taught come to me and said they'd seen a flat Earth video online, and it was one of Dell's videos. And this kid was quite a disaffected kid. They weren't really interested in science at all in any way, shape, or form. But when they were talking to me about this, the questions they were asking, it was like, well, why does this happen? Why does that happen? And they suddenly seemed like really enthused and really engaged. So I sort of had a little bit of a brainwave. It didn't work out great, but I had a bit of a brainwave that if I contacted somebody on the internet who was a flat earther, and the only person who responded was Sleeping Warrior at the time. And I thought if I could have some kind of informal chat with them and get their ideas from them, then my class that I was teaching could use that as an idea to kind of form their own investigations, to ask questions, etc. So I actually introduced the idea to the kids I taught as a teaching tool, so they could learn, to think critically and stuff. But on the back of that chat I had with Anthony, I also got, just on the back of that one chat, my YouTube account at the time was flooded with a mixture of sort of praise for it, but also a lot of insults, a lot of accusations towards me. And it kind of, the engagement of that made me think, well, I want to keep going, but I can't keep going using the school YouTube account because that would be wrong, So I started a tax account.
Okay, I see. Yeah. And well, I mean, has anything changed, or have you?
In terms of views of
yeah, you're from your initial idea or impression of, for want of a better word, flat earthers, which is, to be honest, not a label I would necessarily want to use because of the stigma attached to it. But what the hell? There are many ways you could describe it, and has anything changed in that respect?
Yeah, I think so, because I've met also. I mean, I've had offline hangouts with flat earthers that nobody knows about. That I get on really well with, and I might Skype and text and stuff like that. And there are people out there genuinely. They are kind of questioning, and they're trying to sort of reach a conclusion, etc. And some of the people I've spoken to have reached a conclusion, one way or the other. So I think when I first saw it, I thought it was a joke. I thought it was a wind-up. I think the video didn't help. It was, and I'm not criticizing Dell at all, because I know he was doing it tongue-in-cheek, but it was a video where he was pouring water on a football and spinning the ball. And okay, looking back now, I can see that was tongue-in-cheek, but at the time, I thought he must be taking the mickey. This must be deliberate trolling. And so that's the impression I had. But 12 months later, in my head, I've kind of put people in sort of like little different categories. And there are some people out there, I think, that don't believe that the earth is flat and are trying to make money out of it. I think there are people who are very honestly asking questions and not making anything out of it at all. So yeah, my opinion's definitely changed in terms of like the personalities that are involved, but it's more the lower profile personalities that I seem to have communicated better with.
Oh, okay, yeah, understandable, yeah, yeah. Obviously, yeah, I think Dell's video with the ball was one that kind of increased his viewership as well, and of course, it is understood. It is totally understood that the idea is that everything is being pulled down towards the greater mass of the Earth. I mean, but ultimately, I suppose this is the issue that how much do you how much do you leave or have to imagine or perceive or even believe or have faith in that is the case? I mean, I'd have to ask you in the kind of your, as far as your senses go, or everybody's senses, is there anything that would tell us that we are on a globe?
In terms of like just your eyes and your own eyes and ears, like your own perception.
Yeah, I mean, is it possible for you to actually consider that as a detached from all the mathematics or the the things we've been taught?
If you take all that away, if you take all the science away and all the maths away, etc., then and you just go on your own senses and nothing else. Well, history shows people started off believing the Earth was flat, didn't they? People, because to them the horizon looked flat. They couldn't see the curvature. They thought the Earth was stationary because, as an observer, when you stand there, you see the sun, come up, arise and set. You see the moon do the same thing, and it looks, from your own senses that they are orbiting you, don't they? So if you are only using your own senses and nothing else, then it's very difficult with the Earth being so big to come to any conclusion other than it is what it looks like, when you stood on it. So I get what you're saying there, but I think for me, the science is pretty overwhelming. I'm not expecting you to agree. Have I convinced you yet?
oh yeah, that's it. Okay, I'm going back to the globe.
Got it. Brilliant.
All right. Excuse me. Yeah, well, okay. I mean, obviously, what this whole thing is really kind of, I suppose, trying to define what is the science, or the difference between the science and the science fiction. Now,
Yeah.
I think a lot of us, I would say, were science buffs, space buffs. We loved Star Trek or Star Wars, and of course, a lot of us grew up with it. Whatever, Doctor Who and all that stuff. I mean, it was very, very prevalent in the media, and of course, there is that. There's that realization that this is something that's been in our face and told to us, and once you start looking into it, it would appear that, well, actually all we've been given is a lot of this imagery. I don't know if they still show the spinning globe on BBC TV between every break or before the news, but I remember that as being that was a daily thing that we would see. And of course, planets, etc., would get strung up in the classroom. Well, I mean, obviously, okay. What, just if you want to just kind of elaborate on what you really think is the science fact that backs this up.
What backs up the heliocentric model? I think,
yeah.
Without turning it into sort of like a debate.
No.
For me, science, the thing that tells you if your science is right is about predictability and can you make accurate predictions with the models you've created. And I alluded to a couple of minutes ago, didn't I, that when you go back in time, people thought because they were using the senses that the Earth was flat, but there were things that just they couldn't explain using the flat Earth. That model didn't work, and then that model has been built on and changed. And to me, when you look at, for example, seismic waves, when you look at astronomy, there's so many things. With astronomy, you look at the seasons and just so many things that are that give a really good predictability. That are based on the heliocentric model. It's I would maybe I've not seen enough videos, but I struggle to find a flat Earth video that gives a predictability that can accurately predict when will the next eclipse be, and this is the reason why. Where is the epicenter of an earthquake, and this is the reason why. I've not seen that. I mean, is that something that you look at? Because I know I see a lot of your stuff, and you do a lot of observations, and you look at You must live near the beach or something like that. Looks really nice, and
Mm.
you're looking out the sea a lot, looking at boats. But in terms of sort of like explanations and predictions, is that something you've looked at?
Sure. I mean, yeah. I mean, as far as I understand it, that's what you would refer to as a working model. Yeah, the predictions. Is that basically what that means to you when you say working model?
Yeah. So something that will accurately tell me. For example, I know I keep going back to the earthquakes. I think that's a good one, but something that will accurately tell me, where the epicenter of an earthquake is, or accurately tell me what star will be circumpolar at a given place on the planet, etc. Because all of the things that I look at that make predictions those predictions have been built on the assumption of a globe Earth, and they come out to work. And I've never seen one that's been built on the assumption of a flat Earth that has worked. And I think for me, like, because none of it, like, we're all sat on the internet. None of us are PhDs. None of us are professors. None of us are at the cutting edge of science. None of us are at all. So, we can only go off, sort of the limited education we've got. But to me, the ability to have predictions that work every single time does seriously justify, for me, the heliocentric model.
Right. Okay. I mean, yeah. As far as predictions go, I mean, my understanding is that these have always been made for thousands of years without any kind of particular model, and I would definitely say that the heliocentric model isn't exclusive to making predictions. I often hear that as an argument, but the way I see it is that it's quite possible to create any number of models from the predictions that we can make from just making the observations, and I see that being done in this culture and I think many others. So as far as I understand, the predictions have not come from sticking to a model, but from the observations that we can make on Earth, and then creating a model from that. But then you'd have to ask if those observations are a tangible thing. When we're talking about measurement, I mean, would you not agree that making a measurement from an observation and a physical measurement of, say, a tape measure on a desktop is different?
I think, well, if you're making a measurement from an observation, you've got to use calculation, obviously. But I think we all, simple trigonometry would allow me to measure how tall a tree is at another end of a field. But then I could walk to the other end of the field and I could physically measure the tree and see whether that trigonometry matches up. And I think it's kind of beyond doubt now that we can measure the angle to the top of something, the bottom of something. We can measure the distance to it, and that will, in real world, give us the predicted size of that object. So I know what you're saying. If we're just looking at something and we've not got our hands on it, then yeah, some calculations have to come into play. But that's where the predictability comes in that I was saying before. That to me, the calculations for looking at how tall should something look on a flat Earth, or how tall should something look on a globe Earth, those calculations, they're proven, aren't they? In my
yeah, I mean, okay. Well, you mentioned solar eclipses, etc. I mean, this again, the predictions. I wouldn't say are to do with the model, but these are obviously different to the earthbound observations that we can make and the measurements that we can make. So, this is where I think it can be seen as things can be things can be assumed, and obviously, if we can use mathematics to make calculations, we can make certain assumptions and then build upon those, and we can have our model and it all appears to work. But how do we prove the foundation of that model without being able to verify it? Where do you draw the line between physics, science, physical measurement, and the observations.
I think, yeah, I know you're going with that. So like, but again, to me, I put out my channel a while ago, sort of like it was a bit of a tongue-in-cheek challenge to sort of Nathan Oakley, etc., to come up with a shape of the Earth that will explain. See, I don't want to start off with saying, right, the Earth is a globe, so here are here's what I would expect to see if the Earth is a globe, etc. If we start off with the actual observation and then look at what shape of a planet will fit it. So if we do look at the observation of Polaris, for example, and how when we move 111.3 kilometers in one direction, using the trigonometry, we talked about before, we should be able to calculate the change in the height of Polaris that would be needed if the Earth was flat, but on a globe Earth, Polaris wouldn't need to be changing position for different observers. Now, if you look at the observations you make of Polaris, and you start with the observations, then you've got to then find a shape of the Earth that will fit it. Now, while one thing like that, just Polaris on its own, can't completely prove a globe or can't completely prove a certain shape, it can rule out certain shapes. And I think observations can be really powerful in that they can rule out a lot of shapes. And in terms of an Earth that's completely flat, Polaris completely rules that out with the, just sort of like the simple trigonometry. Polaris would have to be at a different height for all the observers. And then if we take, the same approach with seismic quakes and the distribution of the S&P waves from an earthquake, again, that's going to rule out certain shapes. And if we look at circumpolar stars and how we move and calculate which stars should and shouldn't be circumpolar, again, that rules out certain shapes. So these, as individuals who aren't at the cutting edge of science, these are the things that we have to base our, if we are questioning, these are the things we have to base our understanding on. And for me, all of those things rule out all the shapes, leaving only a sphere. And that's really why I started the Baldy Cats channel, because for me it's important that those things are explained, because people who are looking wouldn't necessarily understand trigonometry too well, not understand how to calculate circumpolar stars. They might understand seismic waves, etc. But at least if they've got the understanding, then they can make a more educated guess, So I think I've waffled on a bit there, but I think I've got.
No, it's okay. No, so it's all right. No, because it's good to know where you're coming from. I mean, I think we've kind of all looked into that. We've heard these explanations, and obviously, it bugs me when people believe that a flat earther is ignorant of all these things, because we're not. Because the first thing you do is look into these, and you look into the different possibilities. So for example, I mean, back to the observations. I mean, I must admit, when first looking into it, of course, the sun, the stars, and all that, it dominates the investigations, because of course that is what the globe or the heliocentric model has been built upon, looking up at the stars, the sun, the moon, and the eclipses and all that. So again, this is kind of, to me, this reflects the way we've been taught to perceive or believe that we're on a globe that's turning, because of this idea of a heliocentric model and looking up at the stars and making those predictions. And then throughout history, it came along, obviously there had to be this way to try to, what's the word I'm looking for, to justify what would otherwise be physically impossible, to stick to the outside of a spinning sphere. I mean, again, it's understood that we're talking about something that is placed in space, as it were, with no other influence, and then starting and trying to build it from there up. But, of course, when it comes to observations, they are governed by perspective, and there's geometry there in perspective, which you can call angular size if you like. How much have you looked into that, and what do you accept as being part of these observations?
Well, so the whole predictability I was talking about before, angular size and perspective, etc., are things that we can predict. Like I was talking about the tree before, we're going to use angular size to then predict how tall the tree will be when I get to the other side of the field, etc. So absolutely, perspective is a real thing. I know that I have a very different viewpoint to a lot of flat earthers who may use the Rayleigh criterion, for an example, as the reason things will disappear from the bottom up, etc. But I have to question how much have they actually looked at, Ranty Flat Earth, for example, and I'm not knocking him one bit, but he was in the chat stream of a chat I was doing on Jose Gonzalez's channel not so long ago, and he asked me to explain diffraction, and I explained diffraction and the diffraction limit, and in the chat he popped back and he said, "No, you're wrong," and he'd been telling people his version of diffraction for a long time, and then like a week later he produced a video to say, "Oh yeah, Conspiracy Cats was right with his explanation of diffraction," and that. It just kind of makes me think there are some key individuals out there that are throwing around terms like perspective and angle of attack and diffraction limit and Rayleigh criterion, but don't necessarily understand them. And that's what bugs me a little bit. It doesn't bug me that people are saying, I think I want to question, is the earth flat? I want to question, is the earth hollow or concave? That doesn't bug me. They want to question it. What bugs me is if somebody's just heard a phrase thrown at them, like the second law of thermodynamics says we shouldn't have a vacuum next to the atmosphere. Well, that's not what the second law of thermodynamics says. That doesn't mean that we've got a vacuum next to the atmosphere, but that's not what the second law of thermodynamics says. So what gets me with that is people using that terminology correctly. That's what's important to me, that they actually understand it. And sometimes I feel that, people don't. Obviously, you'll have a different opinion on that. But no, perspective, etc. I have looked into those arguments, but what I've found every time, to summarize really, is that it doesn't really lie with what the explanation what the explanation really is.
Okay, but all right. Geometry, though, would you agree that is that is mainly what governs our eyesight, the way we see things?
So, in terms of like perspective, is that what you mean?
Making an observation is going to, we're talking about, this is something that's intangible, but it's the things that give us this depth perception. It's governed by geometry. Go on.
No, yeah, I'm going to say it's obviously governed by the movement of light and angular size and perspective are all. You can't eliminate those from observations. No, they're always going to be there. I think the thing that we've got in our favour these days is we don't just have our eyeballs, to rely on. We have a whole range of sort of digital cameras. We have cameras that look at different wavelengths. We have telescopes that work in different ways. We have all different sorts of fancy lenses that, and that we can make the same observation with our eyes, with a phone camera, with a P900, etc. And if it is, the shape of our eyeball, for example, having an effect, then what we will see will be different to what we see with the camera. It will be different to what we see with our phone. So I think that's a powerful tool we've got. Yeah,
but I'm still kind of trying to get to that point where, everything we see and the angles of our observation, etc. For example, you brought up Polaris, can you not see that it's possible to interpret these observations in that way, from the simple fact that, moving away from a light in the sky would make it appear closer to the horizon?
Yeah, I totally get what you're saying. Yeah, I totally get what you're saying, that when you move, if you move further away, something's going to appear to be in a different place, etc. But to me, again, it all comes back to that predictability. I know that if I move exactly 111.3 kilometers away, that Polaris will be exactly 1 degree low in the sky.
Mm-hmm.
So it's rather than just looking at it at the entry level of, all right, if I move further away, it's going to look like it shifts position. Well, I can calculate exactly how much.
Mm-hmm.
And then with those observations that I know, if I move in this direction, it's going to drop 1 degree in the sky. But if I move into my left or right or east or west or whatever, it's not going to change at all. I can take all those observations and then ask myself, what shape of the earth will allow those observations. And again, I'd apply the same, like I said, to the seismic waves, to circumpolar stars, to the points of actual rotation in the sky, etc. That's what I would do.
But then, you know, you can, so, I mean, you can see that it would appear that the sun or a star would appear to be in two different places at once, depending on where it's being observed from. Yeah.
So if somebody's at the equator, then it would look obviously like it's almost on the horizon, as opposed to somebody that's on the North Pole. It would appear to those two people to be in different positions. Yeah.
Right. And, you know, again, when it comes to geometry, now I'm not a mathematician and I'm not going to debate you on the terminology and all that stuff, but as far as it goes, you know, we're really talking about ratios, and it appears to me that when we are, you know, if I've said it many times, but perspective is the imaginary curve, and in my mind, and I think many other people's minds, we can see that this. You know, if you apply the same geometry to the observations, then you don't need a curve, because that is happening in the collective subjective observations of each individual, wherever they may be. And so you then get, if you want to put that all together in a big picture, then you can, yes, you can create a curved surface, but you could derive that from a number of people being in different locations on a flat surface. So what I want to know is just, are you able to see that as
yeah. Go on.
Yeah, well, just, you know, I mean, is that, you know, because obviously we, you know, when I say we, I mean people like myself, you know, that we obviously understand how and why it can be perceived that we're on a globe, and understand the history of it, how it's all been put together. But I think what strikes myself and most other people in this situation, when we're looking at this to and fro between the globe Earth defenders and the flat earthers, is that, quite frankly, we can see one or more or two or more different ways of looking at it, whereas I want to know if you're able to see it from that other point of view as well.
Yeah. I think I understand. I do understand the point. You know, that to me, there's sort of like two arguments here. One, which unless I'm misquoting you, in which case let me know. But I feel like the argument that you're saying is that if we know that if we move further away from you know, something that's above us, it's going to appear, you know, to converge. It's going to appear to look a little bit closer to the ground the further we go away, which is, you know, a good general sort of argument. But I feel like the argument that backs the heliocentric model is I can say, right, using the maths of the heliocentric model, I know for a fact if I move X number of kilometers in this direction, it will be this high in the sky. And when I do that, I will be able to measure it accurately using maths that are based on a spherical Earth. But I can't, when we talk about Polaris, I can't find any maths. And I have tried, because I wanted to put these videos. I personally can't find any way of making that prediction on a flat Earth. To me, when I try and make those predictions, I don't know, maybe there's better flat Earth mathematicians out there than me, but when I try and make those predictions, I can never, ever make it work on an Earth that's flat. Yeah, I can predict and I can make the observation and it's going to be correct on a globe. So to me, if I'm going to choose between the two arguments, I have to choose between the one that makes accurate predictions for me. So I do understand what you're saying, but, you know, I've got to go with this one.
Yeah, well, again, I would say that nothing needs changing. The angles don't change. Nothing changes about those observations, and that is how it is. Again, it would come to where is the foundation of the understanding, or the foundation of the idea that Polaris is directly above, say, the North Pole? What has been scientifically done to confirm that, for example, where we're basing a model on observations and what appear to be assumptions? Where is the proof that Polaris is directly above this particular point on the Earth, for example? Where has that been established?
So, well, I've not been to the North Pole, okay, but I have been 111.3 kilometers north of myself and south of myself. I have been abroad, and with the age of the internet now, etc., I'm in touch with people in all sorts of different countries. So even though I've not been to the North Pole myself and looked up and seen that Polaris is there, although obviously I can see that it's pretty much damn near the center of the rotation of the sky, but I can still make those observations myself by measuring the angle from where I am now, going north when I go on holiday to visit friends, going south when I go on holiday, knowing the distance that I've gone, predict the angle that it should be in the sky when I make that journey based on the heliocentric model. And when I get there, I find that it is. But when I compare that to the prediction that I would make if the Earth was flat, then I get a completely different number. And it turns out it isn't. So even though I've not been there and seen, where it is there, I can still observe it from where I am now and where I was a few weeks ago and where I will be when I go on holiday, etc. But I think the point you're making is one of the things that I did pick up when I started looking at the flat Earth stuff was a lot of people are just used to the idea that the Earth is a globe, right? And when somebody presents an argument and says, well, how do you know, etc., people don't generally look into it. People do just generally accept it. And one of the things that I did after I had my chat with Anthony, I was trying to prepare these kids, is I spent a lot of time looking into all these arguments and looking into, what all the evidences would be and what they wouldn't be. And so, if your point is a lot of people aren't questioning, a lot of people are just believing, then I'll accept that. But I know on my own side that I have looked into it on the back of kind of like entering this arena.
Yeah. But it still seems that you're having difficulty accepting that it's, as I said, if the geometry, it's really to me it's quite simple. Obviously, without how can I put this succinctly? Yeah, again, this curve of the Earth, I've kind of put it into other videos, but that's how I believe it to be, because we started with an understanding that there is no way we could really sense that there is any movement, and there is this reliance on a model for the predictions, and then if we just take that geometry, take the geometry as it is, and flip it to the geometry of perspective, then that's as far as it needs to go. Because the idea that stars, etc., are millions of miles away, are all, in my mind, just part of the model and assumptions. And again, it becomes very difficult to prove that. And we have this reliance on people with certain equipment or making certain assumptions, and then we have these ideas about the speed of light, etc., all piled into this, and a kind of an official narrative that's delivered to us, and a way of perceiving it that ignores, to be honest, this geometry of perspective. And of course I can understand that it would be difficult to find any information about that although it is there. I mean, it is discussed among scholars, and very seriously so, because it's a very real thing. So again, would are you able to? Well, okay, you kind of said that you're not really able to perceive both. You're still sticking to the idea that there's only one that you could perceive, or correct me if I'm wrong. Do you have that ability to switch from the geometry of a sphere that we are supposedly on to the geometry of perspective, and just flip it like that?
Well, yeah, and like I said, the whole the whole thing for me is always going to come down to, the predictive capabilities of something, of a model, and if I'm given an observation, then I can apply mathematics to it, geometry or perspective to it, etc. But which model, which perspective mass or whatever geometry, which one accurately predicts what I'm seeing? And to me, that's like even something as simple as like Foucault's pendulum or something like that. The mathematics predicts that on a spherical Earth, but does it predict it on another shape? What possible reasons could there be? What other shapes can I rule out with the behavior of that pendulum? And that's what I want people to is look and say, okay, it's not about saying is the Earth a globe or is the Earth flat or is the Earth hollow? It's like what shapes does this particular observation rule out? And I think that's a really good starting point. Let's take an observation and say, okay, could that observation work if the Earth was this shape, this shape, this shape, this shape? And if the answer is no, get short of them. And do that with as many observations as you can, with as many sort of scientific measurements that we can. And for me, because I've gone through that in my head, I'm left with only one. So it's not a case that I think I'm choosing globe over flat. For me, I can't resolve any of the data or the observations with any shape that isn't a sphere, because I have ruled out the other ones. I don't know. Maybe I've missed them, but are you aware of any sort of model flat Earth that predicts how, for example, Polaris moves in the sky when we move? Like, is there any predictive capability that I've maybe missed? Because you've been researching this a lot longer than me.
Well, I'd say why would we be so preoccupied with defining a model? What's in it for us?
I think when I say model, I mean something that will be able to predict the outcome of, moving across the land, or predict a certain event in the sky or something like that. So I mean, it's not necessarily, well, I suppose it is a physical shape, isn't it? But is there anything that you've ever come across that does accurately predict using sort of like the mathematics, or is that something that is not your thing? You're more into the observations and stuff?
Well, again, I just, my view on it is that the predictions don't require a model. The models, of which there are many, come from the predictions. And to me, that's on an esoteric level. That's what it's telling us, that you can look at the sky and you can look at the stars and the sun and the moon, and you can make you can have all these ideas and beliefs about it. But it's a bit of a trick. It's a bit of a mind trick, because maybe it's impossible to say what's right or wrong. And again, that's why I ask, why should we be preoccupied with defining a model? So again, I don't think models don't necessarily make predictions any more than a clock can make a prediction of what time it's going to be, and we just learn how to read the clock. So for example, the Muslim community over here know exactly the day and the hour that it's going to be the start and the end of Ramadan, their fasting, not from any models, but from looking at the records and from making observations. And so they have their predictions, they have their predictability. And I think throughout all the other cultures that you can look at, that obviously have had some very advanced ideas and made advanced calculations and predictions, they never required a globe to do that. And of course, one of the arguments we're always given is Newton predicted what was it, Neptune, or I can't remember which planets he predicted would occur or be seen or be discovered. But to me, that's just another one of those little stories that's added in there to, put in there in the historical accounts. So I would say that no, you don't require a model to make the predictions. So why do we have this focus on having a model?
What you're saying is interesting me quite a bit, because if you're saying that those things are probably less important than I'm making them out to be, or that they don't sort of provide adequate evidence for something, I'm curious, what is it that makes you accept sort of flat Earth as being the way it is? Like, what evidence have you got for that, which you think's better almost?
Well, yeah, again, flat Earth is a term that's often bandied about, and obviously what comes with it is this idea of a dome and a frisbee in space and all that stuff. I think the whole thing though is we simply do not know. There is a limit to what we know. There's a limit to what we can experience. I mean, there are so many things that we just don't know about who we are, where we are, how it all came to be. And it's understandable that we would love to have those answers. What we're doing here, what's this all about? I mean, these are the burning questions that we all have once we start becoming aware. So, once we kind of get away from the nowness of being a kid that likes to play with mud pies and things like that, we start thinking about, what is this place? Why am I here? And of course, there comes with it this desire to know. And so, and
they're great questions, and I think anybody, no matter what shape you think the Earth is, we all have those questions, don't they? We've all got a burning desire. And from my point of view, I mean, I'm not really religious, but I wouldn't say that science rules out. If somebody had a religious belief, I'm not going to try and argue against it. If there is an all-powerful God, what is to say that the all-powerful God didn't make the world the way it is with the science the way it is? So, why are we here, and what's the purpose of it all? We're all going to ponder about that one, aren't we? It's a great question.
Mm-hmm, mm-hmm. But maybe I didn't answer your question. What was it you actually asked me? What?
It was, to be honest, I think I'm going to rephrase it slightly, because I don't think I phrased that well. But essentially, if the impression I was getting from you is, if we're talking about observations of stars, celestial events, etc., and you're saying, well, they're not really reliable, we can't perhaps rely on a lot of these observations, then would you say that if observations can't fully be relied on, then the Earth could be any shape? Like, are there observations specific to a flat Earth that you've made that you think would only work on a flat Earth? Or do those same kind of limitations apply to that? Could you say that, all right, these observations don't really tell us anything, the Earth could be any shape?
Yeah, okay, sorry, yeah, that's kind of reminded me of what the whole point of what I said before that was. The flat Earth thing, obviously there are many connotations that come with it. So, yeah, it's the thing is, we don't know the limits and the extent of the true dimensions of this place. In my mind, it could be infinite. We're taught about infinite space. So I don't have a model. I don't feel it's necessary to have one, and especially when our true knowledge of this place is very, very limited, and that we've been given one particular way of perceiving it. So to ask me for a model as a replacement is it's not fair. Because that's not the point. The point is that I think natural physics, the way, as we said, the way we see this place, there is there is absolutely nothing in our experience that would give us this impression that we're moving, or we should be moving, or that we're on a what would otherwise be a physically impossible scenario of sticking to the outside of a sphere. And it's understood that what we have are these laws which are created, such as Newton's laws. Of course, it's fine to talk about, again, real physics. And I think this is what I'm really trying to define here is the difference between real physics and the mathematical models that we can all extrapolate and understand as a concept, or again as a model, but where is that really in our reality if all we're doing is looking at the stars, which can be interpreted in many different ways, when it comes to confirming it with real down-to-earth physical measurements and real physics.
One of the I get that. I do get that. Sorry, I interrupted you there. Carry on.
No. But yeah, I mean, real physics. I mean, you've got to admit that there is no physics. There isn't actually any physics that has us sticking to, or anything sticking to the outside of a sphere. Unless you want to give me an example.
One of the things we teach at A-level is something called Millikan, and like a real world tangible example is something we call Millikan's oil drop experiment. I don't know, have you heard of Millikan's oil drop?
This is dropping oil at a certain rate.
No, it's suspending oil drop. Millikan used this to calculate the charge of an electron, which has been sort of like vital in like making electrical components that work, X-ray machines, etc. So an electron has a charge of 1.6 times 10 to the minus 19 coulombs, and I think that's accepted, used real science all the time, creating components, creating smartphones, batteries, rechargeable batteries that work, etc. We know what the charge on an electron is. I think any electrical engineer wouldn't debate that. But the way he figured out the charge of an electron is he took some oil, and the oil had a uniform density, and he dropped it into a vacuum chamber. I think it was a vacuum chamber, but he dropped it into a chamber, and he gave it a static charge on the way in, meaning that they all carried extra electrons. And in this chamber, there was an electric field, and at the top, the plate was positive, and at the bottom, the plate was negative. And as these droplets fell through the air, he had to manipulate the strength of this electric field to actually suspend an oil drop in the middle of the air. And once he suspended the oil drop in the middle of the air, he knew that the electrical attraction, the electrostatic force on that oil drop was equaling the force that was pulling it down. Now, what he used for the force that was pulling it down was essentially the gravitational constant, the mass of the Earth and the radius of the Earth. All of those combined is what he used to calculate the force pulling that oil drop down, essentially the way we calculate weight. So using sort of gravity and then equating it with electrostatic forces, he was able to accurately calculate the charge on an electron.
Right.
And he wouldn't have been able to do that unless he was using, the gravitational constant.
Well, I mean, you can call it what you want. I mean, I've got no problem with calling something a mass, whether it's a drop or a physical form of a fixed density or volume falling through a less dense medium as being gravity, because it's just weight. Of course, we can say it's acceleration, all these different things. We can try to define this terminology, but
that's reminded me. I forgot to say in that. I'm sorry for. Yeah. I forgot to say all the oil drops that he were using. It was the same type of oil that had an identical density. So density was a controlled, control variable in that. The density of the oil drop was exactly the same. Yet he still had to use a different electrostatic force on the oil drops to suspend them. He needed a different field strength to suspend objects that had exactly the same density. which kind of, but he was still able to successfully calculate the charge on an electron while discarding density altogether, but using, acceleration due to gravity and the gravitational constant. So to me, that's an example of somebody using gravity and actually discovering something which has become fundamental. Couldn't do without my smartphone and the internet and stuff like that. So to me, that's one thing that we can.
Yeah, I mean, you can call that real science, and it's real physics. But again, that doesn't, where does that equate to everything on the Earth sticking to? Yeah, again, it doesn't mean that it suddenly breaks the laws of natural physics that we experience, and again, to have us believe or perceive that we live on the outside of a sphere requires complete faith, to be honest, because it's not demonstrable. And yes, we can take real world science and physics and measurements, and we can convert them. I mean, if you're talking about gravity and again the rate that something will fall, it doesn't dictate that it's heading towards the center of an imagined spherical Earth. So give me something a bit more solid.
Well, that's kind of what I was alluding to before. When if I said to you, give me one proof that the Earth is this shape or one proof that the Earth is that shape, what I think is a great idea, and if you're up for this, and you don't have to be. I don't want to put you on the spot. But if you're up for this, we could do a series because I think we're not falling out or arguing. I think we're being quite civil, aren't we? It's going. We could do a series of these where we take different things like perspective, like Foucault's pendulum, or like whatever. We could do like a little series, and at the end of it, say, well, does this rule out a certain Earth shape or does it not? And what shapes of the Earth can we rule out? Obviously Millikan's oil drop doesn't prove that the Earth is round, but what it does do in my mind is it disproves the idea of density being the reason things fall, because objects with the same density required a bigger force. Of the same density required different forces to suspend them in the air. So to me, that's one piece of a puzzle. So no, I'm not going to give you. It would be impossible for me to tell you one thing, just one single thing, other than show you, photographs, etc. That again, that's going down a whole other rabbit hole of are these fake or are they not, etc. But if we piece the puzzle together, and I'm happy to do that, if maybe once a month or once every few weeks or whatever, you want to choose a couple of topics and we could discuss them as, piece that together over the next 12 months if you want.
Yeah, I mean, I think, again, you asked me for what would be my proof of a flat Earth, or to say what the shape is. And again, I don't think it's anything that we can truly define. And yes, we can all have ideas and theories to fit with a particular concept, but where does it end? Where do we ever really get any answers? And again, why should we be trying to define a model that isn't self-evident? It's just not self-evident unless for example, water always flows down a curve. Is there any way that it can be demonstrated that someone's at the point where the water should be going around the curve compared to the guy over there, and it's not flowing?
See, so what do you mean by that? Sorry.
Well, okay, you're standing there and you'll say, okay, there's your horizon, which is supposed to be a curve. And now this is a really good one. I mean, just straight off, what is your idea? Are you looking into it's never been really clarified for me. Are you looking into a bulge that's rising up, or are you looking across a locally flat area that curves away from you? What's your perception of what's happening when you look at a horizon?
Yeah, you know what? That's a great question, because it's all going to depend on the angle that you're looking. If you are looking bang on at eye levels, and this is something else that I'm sure we're going to disagree on, but if you're looking just straight ahead at eye level, then you are looking at something that's dipping away from you. But if you're looking at something that's far in the distance, maybe there's a lighthouse in the distance or something like that, then you are tilting your head down, which effectively gives you a bulge. So, it depends on the angle you're looking at.
Well, basically, I mean, the horizon, regardless of how one might be looking at it, the horizon is basically where the Earth is supposed to be curving away from us, right?
Yeah.
Okay. So you're standing there, and would you agree that if you're on a globe, then you're always standing on top of that globe, yeah?
Yeah.
Okay, so then if you're looking at a curve, however far away it might be, you're looking at the horizon, and to you that's curvature. Whether that's a bulge or whatever it is, it's going away from you. That's where the physics changes, because for someone else who's 3 miles, 5 miles away from you, they should be, for example, downriver from you. They should be experiencing a curve. But what if that was flat water and it's not flowing? Is that demonstrable? Is it demonstrable that someone can be further away from you at where the water should be curving away but not flowing?
And them not see the curve and not flowing.
No, just them not.
Yeah. I'd put it this way: if you imagine that you're sort of, there's a ring road around a massive city, right, and the city is the diameter of the planet. If you're driving along in your car, where you are at that time, the curve of that road that's going around that massive it's going to be barely measurable, isn't it? You're barely going to be able to see it. But far away in the future, you get your P100 out or P900 out or whatever, and you look down the road, you may be able to see just something poking out at the edge of where the curve is, but once you drive to that part of the road, it's going to look exactly the same as it was where you start, from where you started taking the photograph. So it's not going to look any different for that person. They're not going to experience anything different when they're at that point in the horizon,
Yeah, but I mean, okay, in the natural world, without having to imagine things, water flows, yeah? I mean, So if there was a curve 3 miles away from you, then any water there should flow down that curve.
Oh, like a waterfall, I see what you're saying. Yeah, I've got it. Well, I think obviously that's where looking at water finding its level and the way we disagree on that comes in, because the direction of down is different over there.
Yeah, but this should be kind of a fundamental, obvious proof of our natural world that obviously seems to defy any kind of ability to be seen or measured in any way. So why do we not have that observation to confirm the idea that?
Well, I would say that we do. And the frustrating thing is that they will be called fake photographs or CGI, etc. And that's kind of like my response. I would say that we do have the observations, we do have the stream from the ISS, we do. If you're looking for a physical photograph or a physical video,
I'm just really want to keep it simple, on the Earth, someone looking at what should be a curve, and then being able to demonstrate or measure in some way that water doesn't flow down that curve. Because for the guy on top of the globe or on top of a hill, it's going to flow. Water's going to flow. So
it's going to flow down a hill. Yeah, it will absolutely flow down a hill. But I think I can't. conflate the term curve and hill. You know, they're very different. Like the hill is the elevation above sea level, isn't it? Whereas the curve, you know, the elevation above sea level stays the same. So water is going to flow from a high elevation to a low elevation. And I agree with you on that, but I can't conflate the two terms. You know,
it's gonna flow down a curve. I think this is the thing, isn't it? You know, this is what can be demonstrated. So you ask me what my proof is. It's right there in front of us everywhere we look, and to assume that it's any different requires mathematical models. It can't be physically demonstrated. So where do we draw the line between what's possible to demonstrate physically, scientifically, without having to rely on, you know, taking this and that and putting all these different clues together? Surely it should be self-evident. And isn't this what's missing from, you know, I don't think flat Earth would be a thing if it was self-evident. We're on a globe.
Well, no, and it wasn't like we said earlier on. You know, the early days, that is what people did believe, but they did start to take different pieces of different puzzles and put them together and arrive at what we've got today. But I think that might be the biggest place we disagree on. That, to me, you know, I would recommend anybody that is questioning what shape is the Earth, I would highly recommend that they do look at all the pieces of the puzzle. And it will be difficult and it will take a long time, you know, to get your trigonometry and geometry up to speed, to get your thermodynamics up to speed, to, you know, to get your astronomy and your observation skills up to speed. But I think if you've got all those pieces of a puzzle, then you're going to make a more correct decision. Whatever decision you choose to make with that evidence, you're going to make a more informed decision for yourself. And that's, to me, that might be the biggest place we differ. I would urge people to look at all the pieces of the puzzle.
Well, those, again, you know, it's simply demanding the proof of something that is otherwise physically impossible. Okay, you know, where is the physics that allows this to happen, for everything to stick to the outside of a sphere, spinning or not, regardless? I mean, again, we go back to that, you know, the Dell's thing with the water. I mean, we all understand that, yes, you pour water over something and it's going to be, you know, the idea is that it's naturally attracted to the bigger mass. And sure, but the point is that there can't be, you know, this idea, this concept can't be demonstrated.
So evidence for gravity really is what you're after.
No, just evidence of all those things. Evidence that down becomes something different. That water won't flow down a curve. If it's said that the horizon is a curve, then let's see that curve. Let's see water not flowing down that curve.
I would. Sorry, go on.
Yeah, no, it's all right.
Well, I mean, I'd say that, you know, if in terms of gravity, we've got, I think the consensus is there's two options at the minute, and one is that gravity is real, and one of them is that density is the reason things seem to be moving. I know there are other ideas about the Earth accelerating upwards, etc., which to me have just got so many flaws in. But if we're going to look at gravity as one alternative, and we're going to look at density as another, then without any presupposition of which one's correct and which one isn't correct, you know, we should be able to make an observation and ask which of the two fits the model better. Would you agree with that?
No, because they're just descriptions, really. I mean, gravity, density, weight. Weight is density, basically. And of course, when it comes to gravity, it's basically saying, well, this is due to the acceleration of a mass through a less dense medium. But again, it doesn't define the shape of the Earth. Things fall. And everything is of this Earth. So to and again, it's understood when we do study the construction of the globe model that, based on the presupposition that you have the sun at the center, then of course you're going to have a spinning globe to justify night and day in this particular model, this choice of model. And so then the problem comes, well, oh God, how do we get people to believe that we could do what would otherwise be physically impossible? To me, it's very, very simple. Because again, the observations or models are created from the observations rather than the observations being governed by a model. So observations are made and they're very consistent, and a model can be made from that. Again, there are many ways you can make a clock and tell the time. A circle is great. It works very well. And then, but then of course we have this decision, I feel, to put the sun at the center. And everything is constructed from that. And it's basically just a model that, yes, is predictable and doesn't matter if you want to illustrate it like that as a way of keeping time, as a clock, as a heliocentric calendar, as it were. But to say that is our physical reality when it can't be demonstrated is where the problem comes, and where we get this very blurry line between mathematical models and demonstrable physics. And of course, the idea that down, again, we get it. If you have a circle, then down is towards the center of that circle. But where is the demonstrable proof that is the case with everything that we do on Earth? Where's the science for that? Where's the physical measurement of that, rather than the mental gymnastics and the mathematical models and equations that are simply based on 9.8 meters per second squared? And of course, that neatly works out to being almost 10, and most physicists will even refer to this rate of acceleration as 10, just for ease. So all you've got is weight, called gravity, and the idea that there's an external force required to make things fall down. To be honest, it's seen as a leap of faith, because we have to have this in order to perceive that the otherwise physically impossible. Yeah, and again, it's just mathematical equations. It's not demonstrable. So where do we draw the line? Where do we draw the line between real physics and mathematical models, regardless of predictions, and have it as something demonstrable that does not require any further explanation or labels as to what's causing it? But where is that line?
Well, I think there's a few good points you made there. Like the first one, but I do want to talk about the predictability, and I'm going to give a silly analogy. But if I've got two cars outside, I've got a Ferrari and maybe a Vauxhall Corsa, and I want to drive to the Asda, which is just a mile away. Then if I want to assess which car I'm driving at the time, if I want to try and figure out what's in the engine, have I got the Ferrari or have I got the Corsa? Well, I can make an observation, and that observation will be the amount of time it takes me to get that 1 mile away. And if I'm taking 10 minutes, then I'm clearly not in my Ferrari if I'm going as fast as can. It rules out the fact that I'm in the Ferrari. So, okay, that doesn't prove I'm in the Corsa, for example. It rules out the fact I'm in my faster car. And that's a silly analogy, but if we look at it, the same thing when we're making observations about the Earth, we can make observations that will rule out certain things. And, we look at the observations. We're talking about the sun, for example. The observation of the sun does rule out certain shapes of the Earth. It just does when you start applying, mathematics to it, and you start applying predictability to it. You make accurate predictions that just simply cannot be made on certain shapes. And to me, that's really, really important. If I can make a prediction and that prediction comes true for one shape, but that prediction doesn't come true for another shape, then I can rule out the shapes it doesn't come true for. The second, I mean, like the whole, where can I demonstrate, for example, like, where can I demonstrate the sun being 93 million miles away? Well, I haven't got a spaceship. You know what I mean? I've not got a spaceship to that. When we're looking at complex ideas like that, then there's always going to be a certain like appeal to authority in terms of the people at the cutting edge with the big telescopes, etc., that can get that data for us. But if that data helps make perfect, accurate predictions that don't work on some shapes but do work on other shapes, then I'm not going to toss that data out if it's working. Do you know what I mean?
Yeah, but I've got to bring you back down to earth, man, because again, it's observations of the sky, and it's understood that the whole model is built on that. And again, it's to me and many others, I think it's perspective is the imaginary curve, but we're still lacking this physics, real physics, demonstrable physics of something as simple as water not flowing down a curve.
So what would you expect? I mean, when you say like, what would you like to see?
What would you do? What would you do? I mean,
the thing is, water behaves the way it behaves on this planet. So, and the way it behaves on this planet, there's nothing about the way it behaves that disagrees with the heliocentric model. What you have to do to make water disagree with the heliocentric model is you have to say gravity is not real. You've got to take that out. Now, if you say gravity is not real, therefore now the sphere is impossible, well, we can only make the claim that the sphere is impossible because we're saying that gravity can't be real. But if we look at the heliocentric model, gravity included, water behaves exactly as we would expect it to behave. So what I would say, like, what can I show you that will, what would be evidence for you? What do you want to say? Or is it not really about water at that point because it's now shifted to gravity? Because with gravity being there, water behaves the way that we see it.
Well, we don't see it doing these things it's supposed to do. We see it behaving, in this very intrinsic way where if you do that, it's going to flow. If it experiences a curve, it's going to flow. And again, gravity or weight is, this idea that you need an external force to create weight is a requirement for the globe model, because without it, it's physically impossible. So, do you see what I mean? It's like the model is a physical impossibility. So we have to have this kind of leap of faith again, that there's an external force causing everything to stick to the outside of the sphere.
I would say, and this is, I think we're getting down to what it's not really about water now. It's not about things. It's the idea of gravity, because of but I think on my side we've got the Millikan oil drop that I talked to you about that use gravity. We've detected gravitational waves. There's a whole academic fields that uses stuff all the time. But can I ask you what have you seen that makes you think gravity cannot be real? What have you seen that makes you think gravity is definitely not real?
Well, what are you saying gravity is?
Well, that's an amazing question. And I know there's a whole lot of fuss at the minute about, do we use the semantics of calling it a force? Do we have the semantics of calling it space-time? The fact is, we do see non-contact forces bringing things together, however they work. And I know Del's on a minute about some things can be a push, some things can't be a pull, etc. But we do see non-contact forces bringing magnets together. We see non-contact forces bringing electrically charged objects together. And there is clearly, no contact between something I drop on the ground and they are being brought closer together. So if you're asking me, do I understand the mechanics of it? I don't understand the mechanics of it any better than I understand the mechanics of how a magnet works. You know, I don't know how a magnet works, but they do work. You know, so there's nothing. What makes you look at magnetism and electrostatics and then say, okay, something complicated is happening there that's bringing objects together, but it will be impossible for gravity to do the same thing with mass? What makes what completely rules out gravity for you? What makes you think it's completely impossible?
Again, it's not demonstrable. It's not. It is physically impossible. Take a really simple scenario, the fairground ride, where gravity or weight is created by spinning people against a wall, and they press against the wall. But the globe is the opposite of that. It's not physics, you know. So the fairground ride where we're stuck against the wall is real physics. But you know, to have us pulled into a globe is not physics, and again, it's just seen as a necessary idea. The whole thing about gravity is a necessary idea because we know that otherwise it would be physically impossible. Again, because we've got this idea of a heliocentric model, the Earth going around the sun. To me, it's as simple as that. A decision was made to have the sun at the center because of the Gregorian calendar. And again, it all, you know, we can make these observations. We can make lunar calendars. We can make solar calendars. We can make all kinds of calendars and keep time. And it doesn't matter, you know. No, you don't. But you don't have to demand that is our physical reality. However, what we have with this Copernican heliocentric model and the Gregorian calendar, which is obviously being used around the world now. I mean, here in Thailand, they use a variety of calendars, but it doesn't mean that dictates our physical reality just because they follow a lunar calendar and it works absolutely perfectly. No one's saying that we're going around the moon. It's just, that's just how it is. So you have this decision to interpret observations as a heliocentric model. I'd say it's not even totally observable that all these other luminaries are actually going around the sun. It's just an interpretation. Of course, it's one that's stuck in our heads from an early age. But you basically, you know, you have these observations, a heliocentric calendar or model, and then everything else is required to be an explanation rather than saying, having these observations. I mean, you know, the scientific method, for example, should be something that follows an observation, like, oh, okay, we can see a curve and we can see water not going down a curve. How does that happen? Rather than seeing it as a level plane and then saying, oh, but you're on a globe and you have to have faith that at the horizon is a curve, and it does that because things fall at 9.8 meters per second, and so we'll call it newtons, and we'll say that anything falling through the air is an external force, because it has to be.
Oh, so one second. Yeah, go on. Okay. Sorry, Susan.
Yeah. So yeah. Again, you know, right back to the start of it, you just got it's all, the whole model is built on a decision to put the sun at the center, and everything after that is explanations. Nobody sees any. It should be the other way around. If it's science, it's like, you know, we make an observation of for example, if globules of water was just hanging about in the air, we could say, oh well, that's the same as us falling. And but obviously, you know, we don't have that. We don't experience that at all. We don't experience any movement. And again, when people start looking into flat Earth, they look at all these experiments that have gone on through the ages. It's a huge journey, and to revisit and learn and try to find. This is the thing, you see, when people hear about flat Earth and they start to look into it, they actually actively look for, well, what proof do we have? What do we actually have that proves we're on a globe? And frankly, all we see is explanations. And of course, the first page is in, for example, Google. How was the shape of the Earth or the size of the Earth determined? Looking up at the sun. So where are the physical measurements on this Earth? Where's the science rather than mathematical models to prove this idea?
I mean, the Humber Bridge, you're familiar with the Humber Bridge, but the engineers that made that, they had to make the top of the towers. They had to make the top of the towers are further away than the bottom of the towers to account for the curvature of the Earth, and that was accounted for in real engineering, and it is in really long bridges, isn't it?
Well, you could put that into the plans, and to be honest, it wouldn't make any difference. Whether you get this, you could just assume that you needed to do that, stick it in the plans. But really, when it comes to bridge building and things like that, it is just done step by step, and to get it millimeter perfect is. I think again, this is something that a lot of us looked into several years ago, and of course, it comes up as an argument. But it's really not a valid one, because you could say the same about microwave transmissions and all these things. You can assume there's a curve to overcome, but it doesn't mean there is one. And again, this is not something that can be demonstrated. Again, you could look at the water going under that bridge. It's flowing downhill. And so if you're at the top of this ball and there's this downward curve, then what happens? Where does it stop flowing, or where does it?
Is that what you think, though, that the heliocentric science is? Do you think that even gravity predicts water should flow along the curve? Is that what you like? Your understanding of the model, that the model is that it should be flowing around the curve?
No, I'm saying it's just not. It doesn't make sense, because again, if we're talking about horizons being curvature, then a curve is a curve. A curve is a curve is a curve, and so water always does flow down a curve. So at what point does it not flow down a curve?
Well, when we're talking about the difference between curve and elevation,
I'm just
Oh yeah, but it will obviously flow from a high elevation to a low elevation. But I think I've picked up some interesting things that I'm beginning to understand you a little bit more, because to me, like, my whole philosophy is, if something can make predictions that are accurate, but those predictions will be false on a shape of the Earth, for example, a flat Earth or whatever, then we can rule those shapes out, and what we're left with is the globe. And to me, because I know we talked about kind of like off air or over text, like, why do we believe what we believe and do what we do? Well, that for me, it's all about being able to make a prediction, and that prediction becoming true. Using a certain model, but starting off with the observations. If I start off with the observation of the angle of a star in the sky or whatever, right, and then I make that observation, then I ask, well, what shape planet will allow that to happen, whilst being able to give me accurate predictions about future observations. To me, that does it. I'm sensing that there's a lot of distrust coming from you from sort of like academia and the way science is as a whole. So perhaps you're not prepared to even acknowledge gravity as even possibly being something that's real.
Again, it's I see that it's been defined and interpreted, and the whole thing, everything is all down to interpretation. So we have these observations which are interpreted, and This has got to be made very, very clear. I think that there's no distrust of science. There are some amazing advancements that have been made. I'd even say that, for example, the Apollo program is responsible for the phones and things that we have these days. The fact that we can talk like this. Massive leaps and bounds were made in technology without having to have a war. It was a peaceful, as you would like maybe to say, venture. That allowed people to very brilliant minds to come together. They had a collective mission, and so in many ways the Apollo mission, the idea of the getting to the moon was something that spurred on huge technological advancements and real science. Doesn't mean.
Did you believe the moon then?
Sorry?
Did you believe the moon landing then?
I don't think they went. No, I think there's far too many. I don't rule it out, but it's one of those things that looked into a long time ago and put aside for a while, this is it. It maybe that's what happened. It was a mission impossible. And again, it's you ask me whether I believe it. I think the whole thing is belief. And again, science, real physics, real science. There's nothing wrong with that, and there's no denying science. But again, it comes back to this question of, the whole moon landings thing is intrinsic to it, of course, because it would, if they went there and they got it all right, it would appear that they had the science and the physics and they had the knowledge and the know-how to do it. And of course, I think, just imagine if they didn't go. Imagine if they actually turned around and said, sorry, we can't do it. We just don't have the technology or the know-how, or the physics isn't what we imagined it to be. Then I think we'd probably be living in a very different world right now. Yeah.
The moon landing, it was spurred on, or the race to it, whether they went or not, was spurred on with that sort of challenge between Russia and America, wasn't it? And that was spurred on because Russia were the most advanced when it comes to space technology at the time. They were already orbiting the Earth. So the whole idea of the moon race, whether they went or not, was spurred on by the fact that Russia were already orbiting the Earth. So that for the conversation for the moon landing even to have happened, then you go back further to Russia and not NASA, who were demonstrating globe Earth then.
Well, yeah. Again, you can really. It's very easy to. When you look at the way things kind of really work, that. All these different nations, they're all playing the same game, and there's a lot of propaganda, and it's not beyond the realms of possibility that they could just transmit this signal and have them believe that that's what was going on. Again, it comes down to belief. We have to believe what we're being told as a populace by our dear leaders. This isn't, again, it's not against science. There's not a denial of science, but there's also an understanding of how things, how propaganda works, basically, how easy it is to get people to believe things, regardless of what side you might be on, or regardless of what the real motives might be. And a lot of the time, I think the general public don't know the real motives behind certain news events and things like that.
Well, I agree. You know, there's certainly stuff in the media that comes out and is either highly biased or just wrong. You know, I certainly agree with that. But I wouldn't mind asking. You know, you mentioned something then about you know, Russia perhaps not being an entirely separate entity from America, etc. But one thing we've not touched on is like the conspiracy side of it. You know, if we put the science on the back burner for a second, then we just look at the people and people involved. And I know this will have been put to you loads of times, but I'm just interested in what you've got to say. The conspiracy wouldn't involve just NASA; it would involve, you know, all seismologists, all astronomers, or, you know, politicians, amateur companies, private companies, and communication companies, governments across the entire world. Governments from two countries who are at war, who hate each other, would have to be also in the background, you know, collaborating on this. And the size of that conspiracy, and for nobody ever to have come out, even on the deathbed, and said, you know what, yeah, I was part of this conspiracy, because all other things get, you know, there's always people making deathbed confessions about one thing or another, but as far as I'm aware, nobody's ever come out, even on the deathbed, and said, I'm part of this. But all these countries must be working together. So who's running that? Why do we still have wars? How does that? How I can't imagine how something like that could ever be pulled off.
Very easily, because you don't have to have so many people involved. How many people would really have to know if, for example, people didn't go to the moon? And you know, we have this, you know, we often hear, we went to the moon, we know this, we know that, and there's this collective idea that a whole bunch of people just, but you know, to send a rocket up and it just goes off, so you just need you only need a handful of people that would ever really know. Everyone else is just doing their compartmentalized job, and they have that belief and they have that faith that what they've done is contributed to this this event. And just for example, there's a bunch of people, a small group of people that worked on the project. I can't remember, was it Cassini, I think, did that go to Jupiter, Saturn, or whatever? And so basically you've got this room you've got this room of a few people, a very few, you know, five or six people that spend their time running computer programs to work out the best path for this satellite to take. And they're based in the UK, and they have this connection, a computer, an ancient computer that's connected to the Jet Propulsion Laboratory, and that computer is in a locked room. Only one person can go in there. If the door is opened for any amount of time, then an alarm goes off in the Jet Propulsion Laboratory. And so basically they brainstorm these simulations, and then they go and announce which one they think would work best. They send that to the people at the Jet Propulsion Laboratory, and all they're given is they get back a signal. And so they don't know that what they've done or the simulations that they've run have actually become a reality. And of course, they've got no reason to question it. They've got their careers, they're doing something they're passionate about, and they appear to be getting some results. And ultimately, this thing ended up apparently going into the clouds of Saturn. But all anyone ever had as any kind of proof of this was a signal. You know, the machine that goes ding, and that's it. And then of course you have all the TV programs, and everyone else believes that this all took place, and even the people that are involved in the core of it don't actually know what actually took place. So to assume that thousands of people would have to be in on it is not a valid assumption, because they would all be just doing their jobs.
I think if I can expand on that a little bit, though, what I sort of mean, and it might take me a minute or two to get this out because it's a lengthy point, but if we take, for example, seismologists who are detecting earthquakes, etc., they are using science that they believe to detect, the epicenter of an earthquake is based on a spherical Earth. And all the maths and all the numbers that they are using, that they independently use, seems to corroborate that. But if the Earth isn't flat and there is a conspiracy, that means that somebody behind them has invented the whole field of seismology as we know it, but really behind them must be a secret seismology that works on a flat Earth that they're feeding them this information from, because we do detect epicenters of earthquakes. Same with communications across the globe. And bouncing radio waves off the ionosphere and stuff like that. The engineers who are working on that are working on a science. They must be, if the conspiracy is right, working on a whole science that's been invented just for them, so they will continue to believe in the globe. While behind that, there is a secret science that works only on a flat Earth that's being kept from them, and they're being fed information. And then we look at the people who are making observations of celestial bodies and the eclipses and the designing apps so we can predict when the next eclipse will be and stuff like that. They are working off the mathematics of a globe model. So somebody must have invented that mathematics for a heliocentric model for them, but really behind it, there must be secret maths that makes these accurate predictions. And I could name, 20, 30, 40 fields of industry where people are using the mathematics of a spherical model that must be fake, and behind each of those sciences must be a science that works on a flat Earth only, and then they are drip feeding that data into the scientists that think they're working on a spherical model. Do you see what I'm saying? So I don't think it is about one or two people. It must be thousands and thousands that have been able to create not just one field of science that can accurately predict, but two fields of science, one for a flat Earth, one for a heliocentric model. And the one for heliocentric model is being somehow infiltrated by the people behind that who are feeding these accurate predictions and accurate data in from a flat Earth model in numerous fields of industry. So I don't think it's as simple as saying, oh, we could fake a satellite, because I know we could fake a satellite. I'm sure we could. But, all these enormous fields, to me, I just can't comprehend how that could be possible.
Yeah, it's understandable. I mean, it takes it is quite a leap, but no, I think again to assume that there is some kind of secret science, it really comes down to interpretation, and it doesn't take much for a single generation to be, especially since the advent of TV. To be told things are a certain way and to believe them and to carry out their jobs and their scientific study and just interpret those things. To be honest, I haven't investigated seismology too much, but ultimately we don't really know much about what goes on very far under the earth. This is Again, I'm pretty sure it would come down to interpretation, ripples, however that all works. The waves. Who knows how it all really flows through different types of rock and whatever is beneath us. Obviously, there's a lot of water beneath us. I mean, these are very fundamental questions, such as, where does all the water come from? Where did all this stuff come from in the first place? This is not something anyone can actually answer. I mean, we find ourselves in this physical place and we have no idea how it came about. And to me, again, the predictions that can be made, the observations that can be made, to me, it screams intelligent design. That doesn't mean we're talking about an all-seeing, omnipotent God. But it's here and we're here, and I think we're often clutching at straws, and people are very good at making their own interpretation of events, and for a lot of the time, again, there's no need for these secret sciences and things like that. In fact, who actually knows? I mean, yes, when it comes to the moon landings, and if they were faked, then okay, there's a small core of individuals that would have conspired, shall we say? But that is apparent in any industry. I mean, the whole corporate structure. I mean, the word conspiracy is. This is a fact of life. People conspire. Parents conspire against their kids, or kids conspire against their parents, and marketers conspire against the public. So it does become a them and us situation, and so it's totally realistic to see that people do conspire for profit, and they will mislead people. Whether it's to get them to buy a perfume or to believe that, and of course, the communications industry is massive. It's hugely profitable because once you have an infrastructure in place, then you could just charge for information to go to and fro between that. So the whole space race thing, all that, it's really just, it was kind of a bit of a game. Who's going to dominate the scene here, and who is going to, pull off the biggest, the most convincing story, and rule the airwaves, basically. So again, this is not a conspiracy per se that is beyond the realms of human understanding or comprehension. I think it's so and we just see that all around us in politics and everything. The public are fed ideas, crowds are, the whole dichotomy that we're fed, whether it's politics or whatever it might be, it's all very much controlled because they know how people are going to react. And once you have people believing something, then that job done. You don't have to do much more convincing. And again, when it comes down to investigating flat Earth, globe Earth, etc., then of course you do have to study and examine and scrutinize the evidence that we are presented with, in terms of why do we believe that we're on a globe, or why do we believe that money is important, or why do we believe all these other things that go with the modern society that we find ourselves in. Why do we believe that we have to go to war to defend our country? I mean, these things are hugely influential, and it's very important that the masses be convinced.
I agree that there's a lot of things out there that the public opinion is deliberately swayed by politics and the media. And I totally agree with that. We know false flag events have happened in the past. We know that the media will lean whichever way they want it to lean politically, and they have a massive influence. All of that I totally agree with. But there doesn't need to be a conspiracy, or the agenda behind that doesn't need to be the shape of the Earth. Just because we do have the propaganda and the censorship, etc., I can't see the link between that and the shape of the Earth. Why would knowing that the Earth is one shape and we're lying to everybody about it be needed?
Again, it could be simply nothing more than misinterpretation. I'm prepared to put it down to that these people, however many hundreds of years ago, had ideas, and the way I see it again is this connection, things dropping through the air as being, this is why Newton is so celebrated, for example, because he's the guy that came up with the answer to how we can do what would otherwise be physically impossible, to solidify in the minds of the masses the heliocentric model, and something that they had probably been trying desperately to get people convinced of, because it just didn't make any sense, again, to our sensibilities, our sense of reality, and all the other things that go into it, and the lack, to be honest, of physical evidence. So again, it doesn't have to be a massive conspiracy, but it's one that once you have established that belief, can be perpetuated until people say, hang on a minute, the emperor has no clothes kind of thing, where everyone's just going along with it, but then eventually the guy says, well, someone has the balls to actually point some of these things out which do not make sense and we've kind of ignored, because it is uncomfortable. And again, why do we have this desire to get off this rock, leave all our problems behind, not deal with all the other, it's we have this kind of, our attention is directed up there, away from this place, and again, away from really looking at the real physics again of where's the proof? Where is the proof that we are on this spinning globe? It just hasn't come about, but we can see how it has been put together over time, and again, it doesn't have to be a lie. It doesn't have to be. It's a belief that was a misinterpretation, or one of many possible interpretations.
Well, there does have to be a lie at some point when you start looking at, certainly space travel, and all the countries, 70-odd countries have got launch capability in the world. At that point, it does have to become a huge international lie, because if the Earth wasn't round, all those countries would be reporting back, wouldn't they, that the Earth wasn't round? So there has to be a lie. But the thing for me is, you mentioned it yourself, hundreds of years people have been talking about the Earth being round. So if this conspiracy, was put together by people that wanted to control us and shape our destinies or whatever, then they've managed to do that in a world that had no internet, no way of communicating from one country to the next. But yet they've managed to influence the entire globe over hundreds of years. And now, we've got the internet, we can talk to people in different countries, etc., etc. But then, back then I'd have no idea how they could pull it off. But I do believe that there would have to be secret science in the background that allows us to make all these predictions that we can make, but we're using a heliocentric model to make them. If the heliocentric model didn't work, then how are we making the predictions? Well, we must be making the predictions somehow, so somebody knows how everything works. And they've invented the heliocentric science for us to believe, and they are hiding this whole secret science behind, and they are filtering these ideas down to the highest level academics. And they've been able to coordinate that without any internet, any mail, without anybody on a deathbed making a confession. So I know, you say some things don't make sense to you, but to me, that makes so much less sense than the notion of gravity, when we already see non-contact forces bringing objects together, when we've detected gravitational waves, when we've got, the use of gravity and accelerometers, we can predict the time period of pendulums. So to me, that conspiracy, there's nothing that comes close to being as absurd as that for me, and I think obviously that's something else we're going to differ on, but I feel that's a big
what is there to predict though?
Well, we can predict, for example, if we look at the astronomical, we can predict eclipses up until the nth degree. We can identify and track when asteroids and comets are going to be passing us, when some of these don't pass for hundreds and hundreds and hundreds of years. So I know the arguments made in the past that if we can see a pattern in what's happening, but some of these events that we see, some of the transits that we see, some of the arrangements of the planets take hundreds and hundreds of years. And since man started making records, it would have been impossible for them to build up a pattern to be able to predict to the minute and to the day. We can predict tides again to the minute and to the day, and we can predict how high that tide is going to be. Not that it's going to be a high tide, but is it going to be an exceptionally high tide because of the position of the moon? Is it not going to be an exceptionally high tide? We can predict the size of the moon in the sky, depending on its position in the orbit. So not just the moon phases, but the size of the moon that's with as well. We can predict the epicenter of earthquakes. We can, I don't want to go on and on and on, but
yeah, sure, understood. So I mean, I think fundamentally though, being able to make those predictions is evidence, regardless of the mechanics of how it works, but it's evidence that we're in a system that is not really going anywhere, and so it's very precise and like a clock, and to have a clock, then you need a designer. You need to it needs to be planned out. It needs to be again, there's intelligence behind it. I'm not trying to say what kind of intelligence that might be, but really fundamental example. You've got kids, yeah, and when you have your kid, you put them in a very stable environment and you put them in an incubator, and you would adjust the light and the temperature accordingly. The last thing you do is swing that incubator around your head to give them different temperatures and different light. So we have what appears to be this place, an incubator for life, in which we exist, and there's absolutely no reason for that to be moving. And it is quite possible to, let's take observations, for example. We can watch the sun and the moon go overhead, and we can, every day, and we can see that the moon moves at a certain pace. And again, the lunar calendars show us that it's a very regular movement, whereas the sun does something faster or at a different pace, or changes pace throughout the year. We have this very precise timekeeping mechanism, and it can be interpreted or seen as doing those circuits, whether it's zetetic astronomy or all the other kinds of, again, so those predictions have been made for thousands of years in many different cultures without the need for a model. And again, I just, the way I see it is that the models are created from the observations, and it's a cultural thing. So what we have with this heliocentric model is a cultural thing with the Copernican idea, sun at the center, and then again this model created from it. So the predictions don't have to change, the observations don't have to change. It doesn't mean that we're moving. We can have a stationary Earth with a sun and a moon doing their things and the stars doing their things. Of course, it's very difficult to explain or even describe or even know the physics or the mechanics of it, and that is, quite possibly beyond us, and might always be beyond us. But the whole, predictions are not exclusive to any model. The models are created from the predictions, and that's evidenced in all the histories of the cultures and that we know of, that we can determine that you didn't need to perceive the Earth as being a particular shape or thing, or have it moving in order for day and night and seasons to take place. Again, interpretation. It all comes down to interpretation. Yeah.
No, you certainly don't need the Earth to be a certain shape to have, for example, day and night or whatever. You can have day on a flat Earth, you can have day on a globe Earth, but then we make observations surrounding them, and this is all of that. You'll have heard this a million times, but the observations we make that, if the Earth is flat, then we must have a sun that is much smaller and much more localized. We must have one. Otherwise, it will light up too much of the of the Earth, won't it? But when we make our observations, we don't see the angular change in size of the sun that we would expect. So if we're starting as a point of, I don't know what shape the Earth is, but I'm just going to use day and night, the day would require, the flat Earth would require one thing, which we don't see, which is an angular change in the size of the sun. But the heliocentric model wouldn't require that, and what we see fits better with that. And I think, again, going back to the Polaris argument, if I look at being able to, we've been into that in depth before, but again, the spherical Earth model fits better with that. The seismic wave movement through the Earth fits better with that. And so that's how I've made my, that's how I've made my decision.
Okay. I mean, when just your point about the sun, the whole angular size of the sun thing, we have nothing to compare this to. We don't really know what the sun is. I mean, the physicist Eric Dollard, for example, is one of those physicists who has spent a lot of time trying to study the sun, and he can't even put a definitive term on what the sun is. So it's a very unique thing. It's obviously necessary for us to be here, and it's not something that we can really clearly know what it actually is, and to assume or expect it to change in angular size, which from my own observations I see that it does, but it's not. This isn't a prerequisite, because we got nothing to compare it to, and either way, no matter how small or local that sun is, even if it could be a focal point of light, whatever it might be, coming through whatever's up there, then it's not something that we can compare it with. That's a tangible measurement that we can make on this Earth. It's going to be much, much larger than anything that we can actually measure or relate it to or compare it to on the Earth. So we have to. This whole thing about the distance of the sun. This is again, and it's just I feel it's a requirement of the model rather than a measurable fact. And of course, you can say it's this big, it's this far away. Who's going to say you're wrong? How is anyone actually ever going to prove it in the first place, or prove that assumption wrong? And this is what we often see as the problem: is we are given a single interpretation of these observations and told that's the way it is because science says so. But it's not science that's telling us this, because it's not physical measurements. It's interpretations. And okay, you might well have a mathematical model, which is nothing more really than a description, just as gravity is a description of the way things fall, and they have those things. You can't measure, for example, gravity without having a mass. You can't. You might say gravitational waves, but let's see someone measuring gravity on the Earth in the way that you
can do that. We do have instruments like meters that will measure gravity.
You require have a mass in that meter to be moved by gravity, to have weight in the medium of air.
I mean, going back with sort of like gravity, can I if we're going to compare the idea of gravity to the idea of density and buoyancy and resistance, and we forget that we've already measured gravitational waves, we forget all of that. How do you resolve the issue that if something's going to fall just because of differences in density, if you look all around an object, you're going to drop. There's air all around it, and in fact, the less dense air is above it. So what is that directional influence on it? Why would there be a directional influence caused just by density alone?
Well, why wouldn't there be?
Well, if there's an influence, that means it's something influencing the movement of that mass. Now, density isn't, it's a property, isn't it? Like length and color or something like that. It's not a vector. It's not a force. Density is a property of that material. And if things are going to move just because things have a different density, if you're telling me that a ball, well, let me rephrase it like this. If you're going to tell me that this phone here is going to fall in the air because it's more dense than the air, then you're telling me that more dense things fall into less dense medium. Well, the air above this ultimately is less dense than the air below it. So if this is going to fall into a less dense medium, why does it choose to fall down when it's in fact falling into the more dense of the two medium? To me, the fact that we see that all the time completely rules out differences in density as being the sole reason things fall. There has to be another influence on it. I mean, nobody, and this is a common question. It's been asked loads and loads of times, but literally there is no reason, there's no explanation, there's no description, and it goes against kind of like your own suggestion that it's due to density because it's falling the wrong way.
Well, weight is described as density, and again, I went through it in a video the other day. You have this idea that mass, you're not allowed to say that mass has weight, but when it comes, it's still measured in kilograms. But then when you talk about weight, you still use kilograms, and you're referring then the choice of description to being density, its density in a particular volume. And of course, it's a mass in a less dense medium. So the thing is, it's all it is you create that blow up a balloon, as I showed with my kind of tongue-in-cheek video the other day. But the very point is that you have this space, and it's the medium of air. It could be the medium of water. Of course, there are very few mediums to choose from, and then when you have a solid mass, then of course there is a difference. Again, the mechanics is really quite simple, and it doesn't have to go beyond anything more than you create a mass that is more dense and it falls. You create a mass that's less dense and it rises. Again, that happening has
were the predictive, and these are just simple predictions, and this is what I meant before. The heliocentric model, if I'm given the choice of the two models and I'm going to make my observation of it, the observation I'm making is that this phone will travel into air which is more dense than the air above it. Ultimately, it's choosing in that case to move into the more dense medium.
Yeah, but go on.
I'm going to say if density alone is the reason for that, then it does seem to be going the wrong way. It does seem to be going into the medium that is more dense, which would suggest to me that there has to be some other influence on that. And then if I drop this 1,000,000 times or 100 million times or an infinite number of times, it's still going to go into that medium, which is at the very minimum the same density as air above it. But ultimately, if we go far enough, it's going into the medium that's more dense above it. So, to say things fall into a medium that they are more dense than, then I would ask why fall. And to me, it does have to be more complicated than that. It has to be why is it that direction? And I feel like if we ignore the directional aspect, then well, I'd feel that I wasn't, being honest in my interpretation of what I was seeing if I ignored the fact there was a direction to it, because there is a direction to it.
Yeah, but why would you? Again, we have this requirement to have a direction towards the center of a spherical Earth because it would be otherwise physically impossible. So we have to find this way of describing it as, the mass attracting mass. this law that was made up for the globe model. It doesn't, the fact that you pick up something and it falls through the air, regardless of the difference in density or pressure within that medium, doesn't determine the shape of the Earth. The trick is that it was used as a way of making this connection. Say, we've sussed out that it falls at a certain rate, and we can then extrapolate that, this helps us determine the Earth's place in space as what would otherwise be physically impossible. You drop the phone into water, you change the medium, and again, you create the situation, and whether it's a balloon or whatever it is, it's going to rise or fall. It doesn't really have any bearing on the shape of the Earth, but of course it can be used. Once you have that measurement, you can say, we now have a way to explain how to perceive everything being drawn towards the center of mass, and we have this law that goes with it. So
I get that. I do get that. And if we said just for the next sort of like 2 minutes that the Earth was flat, and we took away the heliocentric, model, we took away the sphere, this is still going to move, and it's still going to have a directional influence. So, whether the Earth is round or not, and it doesn't affect the shape, there is a directional influence. So what could that be? It's still going to move into the medium that is ultimately more dense than less dense. So that, to me, says density cannot be density alone cannot be the reason things fall. Density has to be influenced by something else. And to me, it's very simple and a perfect proof that density needs to be influenced by something else. And I know what you're saying, because you're saying, well, once we find out what that thing is that's influencing it, then, that is the thing that's going to make the water stick to a ball, etc. But if that's where the questioning is leading us, do you agree there has to be a directional influence on the phone?
Well, there isn't one until you do something, until you create that situation.
Yeah, but when I let go, at that point, there is the influence has to be more than just density. It has to be directional also. Obviously it's got to be more dense than the air around it, otherwise it's going to float. But the fact that it's going straight down, and that the less dense area is above it and the more dense area is below it, says that there has to be 100% a directional influence on it. It can't just be density alone that's making that fall.
Yeah, but then it's obviously assuming that you require an external force.
Well, I just said influence. There has to be an influence. Gravity. That there's more that has to come. Just that alone doesn't mean that gravity exists. Then you start off with that observation, and then you build upon that, which I think is what the scientists did in the past. But in terms of, is there an influence other than just density? That's a good starting point. And I think this proves that yes, there is an influence other than just density, whether you believe it's gravity or not. I think nobody can deny that there is an influence other than just differences in density. Do you think? Or
well, I do remember what you commented on one of my videos before, where I was trying to get across this point that I'd like to use water and just demonstrate that water is another medium where suddenly things change because you change the medium. And your point was that I think I used a container of water and I'd put something in the water, and then you said, well, if you weigh that, then it's you're going to get a weight.
Yeah.
That's combining the water in the container plus whatever you put into it. And my point is, well, yeah, but then what you're doing is you're weighing a container in the medium of air again. So that all the mathematics is based upon having a mass in the medium of air. But if you go back to having a mass in, for example, you take water and you have a block of water, as it were, it doesn't have any weight or anything until you take it out of the water and put it in the medium of air. While that mass, if you contain water within water, the only influences on it are going to be temperature and other things like that. You might, whatever, and of course air is a little bit different. You could squeeze it and compress it and things like that. But essentially, if you start, the measurements, all the measurements for gravity start with a mass in the medium of air, and that mass is water. You've got the metric system, which is obviously, it's all very handy, and it all works out nicely because you've got, a liter is a kilogram, and then you've got the whole measurement. You've got the foundation of this measurement system, which is really, really useful, works great for the mathematics, and is interchangeable with every other measurement that we make, whether it's temperature, pressure, all these other things. They're all fundamentally based on having a mass of water of a certain density and a certain volume in the medium of air. So you had to take out this block of water from the water, put it into a different medium, a less dense medium, and then boom, of course you're going to get weight. It's going to have weight, but the block of water within the medium of water doesn't have weight, just as you can't weigh a block of air in the air. So if you started there, if you started your measurements there, you'd have zero. But you see what I mean? All these measurements and ideas about gravity, density, mass, they're all based on taking a dense mass and starting off in a different, less dense medium. And great, fine, it works as a form of measurement, and it will go down. A mass will fall, but this does not dictate the shape of the Earth, and it does not dictate the direction of down. So again, this is something we have to imagine. Where is the proof? For example, you have your sphere. Where is the proof that moving from one spot to another changes the direction of down? This is something I've tried to measure myself with aircraft, whatever. And of course, ridiculed for it, because it's thought that I don't understand that, gravity just pulls everything round and the direction of down doesn't change. We all get it. We all understand that it's a very simple concept, and it's understood why we need that concept. But again, there is no proof that this direction of down changes. And so it's just understood that it's just a requirement for the model that you need to consider that mass doesn't have weight, but density, something with density and volume, has weight, and it's described in the same way but slightly differently, so that we can then have an explanation as to how we can stick to a physically impossible ball in empty space.
But I get that, and I get that, whether things fall or not doesn't affect the shape of the Earth. But this is a really important point, and I don't want to keep going back to it, but do we agree that there is a directional influence? And however many times I let this thing go, whether the Earth is flat or concave or hollow or round or whatever, whenever I let this go, it is going to fall in the same direction. If I put it in water and it was more dense than the water, it would fall through the water, but the same thing would happen. It would fall into the greater water pressure rather than upwards. So we know they behave differently in different mediums, the buoyancy is different, etc. But the one thing that we see the same all the time is that when they are let go, if they are denser than the medium they are in, whatever that medium is, they are going to move towards the Earth into the higher water pressure or the more dense air. So they're actually going to move away from the less dense stuff above them towards the more dense stuff below them. So even though density is playing a big part, if it was only density, it would move upwards in whatever medium it was in, if it was less dense than it. So, I mean, as a starting point, surely we have to agree that there is a directional influence on the way things fall, no matter what the shape of the Earth is. Is that that's fair to say?
Um, it would again. It's again simply because that situation was created.
But what do you mean? I don't get. I think that's where I'm struggling to understand you.
Well, like blowing up a balloon, whether it's helium, if it's helium, and you know, there is in this space here, there is no measurement of gravity or density even, but the moment you create a mass or you put a mass in there to be measured or to be observed, then, you know, if you create the mass of a balloon with helium, it will rise. And if you create the mass of a balloon using water, it will fall through the less dense medium of air, regardless of the density that the different layers of density that the air itself might have. The simple fact of the matter is that you've created a mass that is heavy. Yeah. So it's that in itself, just as if, you know, you're going to push on a car, it's an immediate relationship between the car and yourself. Yeah. There is no other explanation required other than the immediate relationship that you create by blowing up a balloon of helium or filling a balloon with water. You create that difference, and it all came from the earth in the first place, or was somehow extracted. So I see what you're trying to say as far as direction, but what does it matter? And
I think it matters, because if we're looking at how things work, then, you know, or looking at like piecing a puzzle together, or just looking to find out, you know, the reality of what's around us, then it's important not to discard any bit of information we pick up along the way. And I think that demonstration, you know, whether, I know you might not think it's important, but to me, it is very, very clear evidence that density alone will not explain why things move. Because if it did, it wouldn't move in exactly the same direction every single time, if that direction is actually in the opposite way that difference in density would dictate. So to me, it's really important. And I know that's only one small piece of the puzzle, and it doesn't determine the shape of the earth or anything like that. But I feel like we can't ignore things like that. You know, to me, that is a clear indication that there's a directional influence. And if I push that out of the way, then I'm going to make wrong decisions and wrong conclusions down the line about other things.
Well, what creates that influence then? What in your...
Well, that's the question. Now, that's the question. Now, you know what I would say, but it doesn't mean you have to agree with me. You don't have to agree that influences gravity. You don't have to, you know, agree that influences anything. It's what I would say.
Well, I'd say what's creating gravity?
And that is also a fantastic question. If let's say we call that influence gravity, whether it's the same gravity that Brian Cox talks about on TV or not, if we just call it gravity as a directional influence, then we're referring to the same thing, whether we're going to call it a force or whatever. You know, I can't explain, for example, how magnets work, right? I can't explain at a real sort of like deep level how magnets repel or attract. And I can't explain at a deep level how electrostatic forces make things move. And I can't explain at a deep level what is causing that directional influence. But all I can do is make observations that tell me that directional influence does exist. And then I can build upon it and maybe ask other questions. But if I'm going to ignore the starting point of, there is a directional influence, then I'm never going to go down that road. So, you know, I can't explain it. I can tell you what textbooks say to a high school level, but if you want to know, if you want somebody to explain that in full, you need someone who's a cutting edge physicist, and it's not going to be me. And I wouldn't even pretend it was, but.
But yeah, this is it, isn't it? You know, ultimately it comes down to this simple, and it is a fundamental fact that we don't know. Nobody knows this place. And I think, again, we're always, all of us, and it doesn't matter how many degrees they have or whatever, it's unknown where we are. And so this is, and this is why we demand the proof. If someone's going to make the claim that we're on a spinning ball and we're stuck to it because of gravity, but you can't really prove anything other than saying, well, okay, essentially dense things fall through less dense mediums for whatever reason. And of course, the old idea is that the Earth is a specific mass. And again, this is something I went through in a previous video, that once, for the mathematician, once you have the assumed dimensions of something and you have understanding of density, and you have a way of measuring things being a certain density or having a certain weight, then you can simply build your model and say, well, the Earth has a certain mass, and a spherical mass works very well, and then we can kind of just calculate and make this model based on these assumptions. But ultimately, this is the thing, isn't it? This is what we're all looking at, is where are we and where's the proof? And I think it's wide open. It's still wide open to exploration, and I think it's very clear to a growing number of people that while there are descriptions and explanations and mathematical models, there isn't the scientific proof. And of course, it's understood that it all appears to work, and we can all perceive it. But it's not ridiculous. We should be allowed to explore a multitude of ideas. The possibilities are endless, because no one actually has the answers to how all of this came about, where we are, where we actually are, what this place is. And of course, it's frightening. It is frightening to not have the answers. And this is what we see a lot of the time is desperation to explain it. And understandably so. But if there aren't, if there isn't a, again, because you keep talking about predictions, and yeah, you can predict that things will fall, and this is what's been. That's how they've been able to solidify this model by saying, well, we can predict the movements of the stars, and we can predict that something will fall at a particular rate. And so this connection has been made. And this is why they're referred to as math magicians, because they are seen as these gurus that have the answers to life, the universe, and everything. Simply because you drop something, we can measure the rate of acceleration that it falls through the air, and we can say, ta-da! This confirms our model. This allows us to make all these other calculations. And when in fact all it is doing is relying on the predictability of it to create this illusion of certainty.
Yeah, no, I mean, I can see I think I understand where you're coming from a lot more. I think that's been a really beneficial sort of like side of this chat. For me, hopefully you understand where I'm coming from, in that, to me, the ability to make predictions on a model that then come true in reality is very powerful. And if it can be done time and time again, I think that's very powerful, especially if and this is the thing for me, if the ability to make those predictions on other models or other shapes of Earth isn't there, but it is there just for one model, that's very powerful for me. And for me, it's all there for one, and it's not there for another, but I appreciate, I've listened to what you've got to say, and I know you don't, put the same significance on that. But I've probably only got about another 5 minutes.
Okay, I was going to say, yeah. Well, let's quickly have a look at the chat. I'm really sorry to everyone for ignoring the chat. I think it's hopefully been beneficial to let people hear both sides. Has anyone got anything they want to say or ask or clarify in the 5 minutes that we have left? Then just basically, I suppose the best way to do it is to just, again, I'm not trying to promote any kind of hate or dichotomy here. I just want to see if it's possible to build some kind of mutual understanding and let people make up their own minds about how, at least, so Celtic. Okay. Again, yeah, it's asking, ask Katz if he can actually practically demonstrate his beliefs using tangible substance.
You can take water and you can drop it. I haven't got an elevator shaft here, etc. There's plenty of examples of water being taken and dropped and conforming to a sphere in free fall. Obviously, I'd mention as well, if you're looking at the ISS and water up there, it will conform to the outside of any shape that it's stuck to. In microgravity up there as well. But it's a bit of to talk about that is it's a deliberately, I think, obtuse question. Can you show me water conforming to a ball when we have a planet underneath our feet? We are stood on a planet. So if I'm going to get a ball and pour water on it, well, I need to be doing that in the absence of the planet underneath my feet. So to claim that because I can't do that with the planet underneath my feet means that, the heliocentric model is wrong and all the scientific research is wrong just because I've got a planet underneath my feet is it's a bit, to be honest, it's a bit of a cop-out question for me. So I'll pass on that one.
Okay. Yeah, I think we touched on it, and I think, yeah, that still remains my personal stance and that of many others, that it requires, if we're being told that something is our physical reality, that to be honest goes against all practical demonstration, then it really needs to be demonstrated in a simple way. And again, just things falling isn't going to cut it. It's got to be more measurable and demonstrable than that. But okay, there's the chat's going wild, and I'm sorry if I can't keep up with this. Rune Thorson says, I want to ask him how to draw the line between obvious conspiracies, as in controlled by a small group hidden to a large group of people, and a conspiracy too big.
Good question. I think everybody's got a different line, though, haven't they? I mean, I don't want people making the mistake of thinking that I'm absolutely 100% mainstream, and I don't think that censorship occurs, and I don't think that there are, there are conspiracies that have validity to them. But where we draw that line that's really subjective, isn't it? I think I've drawn the line, or I've articulated today where I've drawn the line at the conspiracy hiding a flat Earth. But no, it's a good question. I think the take-home point for me is that there is misinformation out there on a lot of things, and there is censorship for a lot of things. But I tend to think those are more political, more media enforced with political agendas rather than scientific. Let's hide the true nature of this or the true nature of that.
Yeah. It's a difficult thing to comprehend, possibly the scale of it. Okay. Any more questions? I mean, obviously this. It'd be good to look at the feedback, and it'll be good to look back through the chat. I'm sure you'll do the same, Al. And
I will. Everyone's got like 2 minutes to get the last "call me a wanker" out, because I'm sure there's been a few of them. So, let's count up how many wankers I get.
Well, I've had a few on my one of my latest videos.
We all get them.
Yeah. But yeah, I think also, if I can just say something to kind of round this off, I think ultimately this is what we're looking at is the difference between subjective reality and objective reality. And okay, sorry, I'm getting a thing from Authentic Intent. Because the water is inside of a container minus the resistance of the air outside the container, a raindrop is not a sphere. Okay, I think referring to what you were talking about.
Oh yeah, I wasn't referring to raindrops. I was talking about water falling in microgravity. But yeah, I see the confusion. But it wasn't raindrops I was referring to.
Okay. Yeah. Yeah. Just to kind of finish off my train of thought, the way I see it is that our subjective reality, when it comes to all these observations, etc., has been replaced with this kind of subjective perception, and everything's been standardized. And I truly believe, for want of a better word, that that's the way it is. I can understand and I can see how the whole globe idea, heliocentric idea, has come about. I'm not blaming anyone in particular. I'm not saying it's in fact, what I see is this, what appears to be a massive grand conspiracy and deception, which it doesn't actually have to be. Again, it could be just a misinterpretation or one of many possible interpretations. And we don't necessarily need to be blaming each other or calling each other out or calling each other names for thinking or believing that it might be this way or the other way. Personally, I've become very detached from that, and my mission is to say, okay, that's the way it is, and we're having a very subjective personal experience on this earth, and that's really why we're here. And any and all interactions that we have consequences, and there is, and that's the same science that you get from every action has an equal and opposite reaction. The interactions that we have as people in this existence, whatever it is, have consequences. And I know personally it was a tough thing to face, and I believe that in some ways what we're being told to believe is our reality can excuse us, allows us to excuse ourselves from the interactions that we, or the karma that we might create. And again, just the simple fact of putting the phone in the air creates a direction. It creates, something happens, and we create that. So we are constantly creating. And as far as the mechanics of how it all works is beyond us. And I'm happy with that. I'm happy to not have to feel that we need an explanation other than to be in it and experience it. So anyway, I'm kind of eating up your 2 minutes. Is there anything you'd like to finish off with?
No, I've just really enjoyed it. I think it's valuable every now and then that we have these conversations and sure we can have the discourse, but for me it was just important to try and find out why you think what you think. I mean, I'm fairly solid in what I understand, but it has been important for me to see why you think what you think. That's been useful. But I think if anything, we can build on this and maybe do more stuff like this, or maybe look at ideas like perspective, look at ideas like refraction, look at ideas or whatever, and maybe even each put a video out on them, let people have a look at them, let them see the arguments for both sides for themselves, and we could work together to help people make more informed decisions. I'm happy to have more communication like this.
Okay. All right. Well, I appreciate it. And I'm sure a lot of the people watching do appreciate this too. So thanks to you, and thanks to everyone else for coming along and sharing, and hopefully some kind of progress has been made, however that might be perceived. You there? You've gone quiet now.
I was watching the watch page. It looked to me like you were still talking. I wasn't watching the hangout.
Okay.
I thought you'd gone quiet. I forgot there's a delay in there.
Yeah.
I can't hear him anymore. Oh, thanks for that, Nick. I appreciate that.
Okay, nice one. Yeah. All right. Well, okay, we'll wrap it up now. And again, thanks a lot to everyone who's come along. And obviously we're all going to just go our own directions and keep on doing what we do. So for now, salute you for coming on, and maybe we'll be in touch again.
Oh, we are still live. Sorry, that minute ago I thought you'd ended the stream. That's what the confusion was. Right, sorry, I didn't realise we were still live. Bloody hell. Okay. Cheers.
Okay, all right. Cheers then. Okay.
Bye.